Okay, today we're going to be looking at solving trigonometric equations. And we're going to solve these equations for x. And we know we're going to have sine x, cosine x, secant x. So we're going to have to look at our unit circle and figure out these values, okay? The first few examples we'll do, we're going to solve for any value of x, and then we'll do some for a specific range for x. The first example we're going to look at today, we want to solve 2 sine x plus 1 equals 0. Now, when we solve an algebraic equation, we want to get x on one side by itself, okay? And what we want to do here is to get that trigonometric function involving x on one side by itself. So, I need to do what to both sides? Subtract 1, and then do what? Divide by 2. So I have sine x equals negative 1/2. Now what I want to do is to look at my unit circle, okay? And I want to find all sine values of negative 1/2. So if I look at my unit circle, remember sine is that what? Y coordinate of that point, right? So sine being 1/2 occurs at what? 7 pi over 6. And what else? 11 pi over 6. Now, I'm not done yet because this only gives me the values for x from 0 to 2 pi, right? Right? How do I get any value of x that has sine value negative 1/2? Well, I need to go back to the period. What's the period of sine? Just plain old sine x. 2 pi, right? So what I need to do, my solutions will be 7 pi over 6 plus 2n pi, because 2 pi is one period, 4 pi is another period, so I need 2n pi, and x equals 11 pi over 6 plus 2n pi. These are my general solutions. I have to put that plus 2n pi because sine has a period of 2n pi basically. If you remember, cosine has a period of 2n pi, or just plain cosine has a period of 2 pi. Well, we put that n in there to denote that I can go 2 pi, 4 pi, 6 pi. Okay? Tangent and cotangent have period what? Pi, so we say what? N pi for tangent and cotangent. But sine, cosine, cosecant, and secant, they all have period. For a general solution, you want to add plus 2n pi for those. And for tangent and cotangent, plus n pi. Now that is if it just says find solutions. The directions may say find all solutions from 0 to 2 pi, and then these will be our answers. So it depends on the directions. But here we're finding all solutions. Let's look at another example. Tangent x plus the square root of 3 equals 0. Well, I need to get tangent x on one side. So what do I need to do to both sides? Subtract what? Square root of 3. So tangent x is negative square root of 3. So looking at my unit circle, what does that mean? Tangent is what? Sine over cosine, right? And if I look at my unit circle, I see square root of 3 in there, but I see what? Like for if you look at pi over 3, it has cosine what? 1/2, and it has sine square root of 3 over 2. Will that ratio of sine over cosine give me square root of 3? Will it? Sine over cosine. It will, won't it? But I'm looking for what? Negative. So I need to find what? A sine value, or sine or cosine value. One of those needs to be negative. But I need cosine value 1/2, sine value square root of 3 over 2. 5 pi over 3. Where is that? Okay, yes, 5 pi over 3.
Does it matter to use the second or fourth line?
It does. So you can't use 5 pi over 3 because tangent, what is this domain? We got to think about the domains again. Tangent. What is the domain of tangent? What's the domain of tangent? Or one period of tangent can occur between 0 and pi, right? 0 and pi. Pi is its, what am I trying to say? It has a period of pi. So we look from 0 to pi.
How about 2 pi over 3 and 5 pi over 6?
Okay, 2 pi over 3 is between 0 and pi, isn't it? So, will that give me 2 pi over 3 has what? Sine value square root of 3 over 2, and cosine value what? Negative 1/2. That does give me what? That does give me my negative square root over 3. So I would say what? 2 pi over 3. So I'm looking at my period. Period of pi is between 0 and pi. Right? It's pi, so we go from 0 to pi. So between 0 and pi, is that the only angle? Is that between 0 and pi? No, not 5 pi over 6. And let's say why. 5 pi over 6 has cosine value negative square root of 3 over 2. Remember, tangent is what? Sine over cosine. So that square root of 3 needs to occur with the sine value for it to be the numerator, right? So is that the only value between 0 and pi? Yes, it is, isn't it? Now, I need to add n pi. And why do I add n pi to that answer? Because the period is n pi.
So, cotangent is the same way. You can only use it in the first and second quadrant.
Right, 0 to pi. Because it has a period.
I see why it wouldn't be that now.
Okay? Let's do a cotangent 1. We have 3 cotangent squared x minus 1 equals 0. Let me get my cotangent on one side. So I have 3 cotangent squared x equals 1. Or cotangent squared x equals what? 1/3. So cotangent x is what? Plus or minus the square root of 1/3. Why is it plus or minus? Square root. Square root. Positive and negative. So, and I know that my answers are going to I can't look for cotangent with it like this. I need to do what? Rationalize, right? That denominator. So cotangent x is plus or minus what? 1 over the square root of 3. Because square root of 1 is 1. So cotangent x, we're going to look for plus or minus what? Square root of 3 over 3.
How did you get it like that?
From here to there, the square root of the numerator, square root of 1 is 1, square root of 3 is just the square root of 3, and then we rationalize.
How did you come up with plus or minus?
When you take the square root,
Okay.
it's plus or minus. Yeah, think about the quadratic formula.
Okay.
Plus or minus is before that square root because there are 2 roots for a square. Okay? So now, I look back at my unit circle. I need cotangent between 0 and pi. Now, cotangent is what? Cosine over sine, is it not? So, I need some square root of 3's. Where do the square root of 3's occur? Okay. We're still looking between 0 and pi. Okay? Still looking between 0 and pi. We want the square root of 3 over 3. I probably should have left it as 1 over square root of 3. Let's leave it as 1 over square root of 3 because there we can probably see better, okay? Because I can't get square root of 3 over 3 as a ratio of sine and cosine, but I can get the square root of 3. Let's think about square root of 3 over 2 and 1/2. Let's think about that.
2 pi over 3.
plus n pi?
It is 2 pi over 3. So we want to leave it like that and not rationalize. Okay. So let's look at this again. 1 over the square root of 3. If I look at pi over 3, pi over 3 has cosine value what? 1/2, right? Tangent is cosine over sine, and it has sine value what? Square root of 3 over 2. So this is 1/2 times 2 over square root of 3, which is 1 over square root of 3. So for these kind of problems, maybe it's best not to rationalize so we can kind of see these ratios better. So this means that one of my x values will be pi over 3. The other value, now that value occurs in quadrant 1, right? And he just mentioned there is a quadrant 2. Or is there a quadrant 2? Yes, because we want plus and minus. This gives me plus 1 over square root of 3. Going to quadrant 2, where now cosine is negative 1/2 and sine is square root of 3 over 2, then this gives me 2 pi over 3. That gives me the negative of that answer. Do we see where this comes from? No? Yes? Okay. What do I need to add to this? N pi. So it's probably best that we not rationalize in this case because we can see this ratio better here than looking at the square root of 3 over 3. Okay? Any questions? All right, let's look at another one. Sine squared x equals 3 cosine squared x. Now there are a couple of ways we could go about this problem. We could either convert it to sines or cosines, okay? But we have to convert it to either one because you need to solve for a sine or a cosine. So let me go ahead and subtract 3 cosine squared x, or bring it over, okay? I can replace cosine squared x with what? 1 minus sine squared x, one of Pythagorean identities, right? I could have chosen to convert this to cosine. It would not have mattered, okay? Would not have mattered. So I have what? Sine squared x minus 3 when I distribute, plus 3 sine squared x is 0. So what do I have? I have 1 sine squared, 3 sine squared. Add that together gives me what? 4 sine squared x. I can take or add 3 to both sides, equals 3. Remember in our verifying identities the other day, it said, you know, you may want to convert the sines to cosines. Cosine squares and sine squares, they go together, like secant and tangent and cosecant and cotangent. I can divide both sides by 4. So sine squared x is 3/4. So what's sine x? Plus or minus the square root of 3 over the square root of 4, which is what? 2. So, do we all have up to that point? Now, what sine values or what angles have sine value plus the square root of 3 over 2 and minus the square root of 3 over 2? And we're looking from what? 0 to 2 pi. With tangent and cotangent, we look from what? 0 to pi. So, sine square root of 3 over 2 and negative square root of 3 over 2. I have what? Pi over 3 plus 2 pi, right? I have what? 2 pi over 3 plus 2 pi. I also have what? 4 pi over 3 plus 2n pi. And I have another one, which is what? 5 pi over 3 plus 2n pi. We're confused.
Okay. So we're looking where our sine value is square root of 3 over 2.
Positive and negative.
So there's square root of 3 over 2, but it's split 1/2.
No, it's with 5 pi over 3.
Oh.
Sine is what? The second coordinate.
Okay.
Okay? Anybody else confused?
All 4 of them are our answers.
Yes, all 4 of them. We normally block our answers in, don't we? We just ran out of space. We know practice makes almost perfect. Almost perfect. Okay, the next field we want to find all solutions in this interval 0 to 2 pi. And this simplifies math because we don't have to worry about adding n pi or 2n pi. We can just get our angles, okay? We can just get our angles. Secant squared x minus 1 equals 0. So secant squared x equals 1. So what is secant x? Plus or minus the square root of 1, which is what? 1. Now, I have to remember what secant is. Secant is 1 over what? Secant x is 1 over cosine x. So, in order for me to find the values where secant x is positive 1 and negative 1, I'm going to have to find the values where cosine x is what? Positive 1 or negative 1, because I want that ratio to be positive 1 or negative 1. So what values between 0 and 2 pi, not including 2 pi, because they count 0 and 2 pi to be the same thing here. What angles give me, okay? Angles give me cosine value positive 1 and negative 1? Positive 1 is what? 0, right? Cosine is the first one. So that's 1. I go on around. Negative 1 is what? Pi. And that's it, isn't it? That's all, right? I don't have to worry about adding plus 2n pi because I have a specific interval that I'm dealing with. Okay?
Would you know it? Did y'all put that on the 2 pi?
No, you wouldn't, because they wanted, no, 2 pi, look at this interval. 0 is closed, 2 pi is open. 0 and 2 pi are coterminal, right? So they include 0 and they don't include 2 pi. We just use 0 because they're the same thing. But they specifically said we include 0 but don't include 2 pi. Question in the back.
Why would it be pi? Is that the negative 1 in the value or not?
Remember, cosine is x. Sine is y. Yes.
That's final answer.
Yes, final answer, because this interval we don't have to worry about adding those other periods.
When it adds for specific range, right?
Yes. Was there a question in the back? Right, because they say find all solutions between 0 and 2 pi. So we don't have to worry about other intervals. See, adding 2n pi here would take us all the way to 4 pi, 6 pi, 8 pi. They say stop it at 2 pi. And these are the values that you actually see on this circle. You don't have to worry about the others.
So the other one is like can go forever.
Right, because they're what cyclic functions continue. That sine wave continues on, continues both ways. And so does cosine.
So are those questions really viable for an answer in particular? Or is it just to give us the idea?
You mean in the real world?
Yeah, I mean, it makes sense, but that one is like, what is that solving for? What is that, if it just goes on forever?
Now, what are solutions? They're the x-intercept. So they tell us the places where to go across the x-axis. So, I don't know. Did I answer the question?
Yeah.
Okay. Let's go ahead and put this one over here. We need a little space here. The next example. 2 sine squared x equals 2 plus cosine x. Now, we might need to change this sine squared to cosine so that we can have cosines in the problem, right? So what is sine squared? 1 minus cosine squared. I can go ahead and bring over this 2 and bring over that cosine x. Right? Go ahead and bring those over. So let me distribute. I get 2 minus 2 cosine squared x minus 2 minus cosine x equals 0. This 2 and that negative 2 cancels, right? So I'm left with negative 2 cosine squared x minus cosine x. What can I do here? I can factor out a negative. In fact, I can factor out a negative cosine. So I have 2 cosine plus 1 equals 0. Right? Now I can use the property of zero products. Yeah, I remember that one. To say that negative cosine x is 0, or what? 2 cosine x plus 1 is 0. Here I can divide both sides by negative 1, so I have cosine x is 0. Right? We can break these up, right?
You lost the answer with factoring.
Okay? We can break these up because remember, the property of zero product states A, B equals 0 means A is 0 or B is 0, where A and B are algebraic functions. Or here, trigonometric functions. Okay? So this is like our A. So negative cosine x equals 0, or what? This portion here, 2 cosine x equals 0. So negative cosine x equals 0. I want cosine over there by itself. I can either multiply or divide both sides by negative 1, right? To get cosine x equals 0. Here I need to do what? Subtract 1 and do what? Divide by 2.
So if you do that on the cosine x side by negative 1, you have to do it on the other side.
No. Because we took this whole expression as our A and this whole expression as our B.
We really only need to do 1 and 2 to find it, right? Like we either had to work out when you factored or what was left, right?
I don't understand your question. Say that again.
Like for the or
Uh-huh.
right there, we didn't have to do both of them, did we?
Yes, okay. For instance, let's go back to algebra. If I have x squared minus x equals 0, right? I can factor out an x and be left with x minus 1. How do I solve this? Either x equals 0 or this portion x minus 1 equals 0. Remember? That's the same thing we're doing, the property of zero products. Does that help to see it in the algebra form? So, what angles have cosine value 0?
And this must be 2 cosine x. That are at the very bottom. Where you got negative 1. Oh, never mind. You moved to it.
Mm-hmm. All right, y'all. Cosine x is 0 where? So x is pi over 2 and what? Okay? And we have cosine x is 1/2 where? 2 pi over 3 and what? 4 pi over 3. So those are my answers. Okay? Boy, this sheet's going to come in handy, isn't it? Still have to be familiar with the concepts, though. It seems like we have a better understanding of this stuff versus other things we've done, which is good. That's good. Okay. Suppose we have secant x, cosecant x equals 2 cosecant x. She says, oh boy, it won't be that bad, hopefully. No, we can think about, you can't convert it, but you can think about bringing over that 2 secant or cosecant x, and then we can factor, can we not? We can bring out a greatest common factor of what? Cosecant x, and be left with secant x minus what? 2. And now we can use that same property, the property of zero products, right? That says cosecant x equals 0, or secant x minus 2 equals 0. So we have secant x equals 2. Now, I need to find solutions for both of these. What is cosecant x? One over sine, right? 1 over sine. Can I ever have it where cosecant x is 0? Let's think about that. In order for us to get 0 as an answer, you have what? Numerator 0, denominator non-zero. Will that ever happen? Can I ever get 1 over sine to be 0? No. So, this will never happen. So there's not a solution for that portion. Okay, let's say it again. Cosecant x equals 0. Cosecant is 1 over sine. In order for us to get cosecant x to be 0, the numerator would have to be 0, and this non-zero. This numerator can never equal 0. 1 will never equal 0. So there are no values for x that have cosecant value 0. Okay? Now, it doesn't mean we don't have a solution because we still have to investigate this. Right? It means this portion won't lead me to a solution, but this portion may very well. What is secant? 1 over cosine. Okay? So I need to find values where 1 over cosine gives me 2. And when will 1 over cosine give me 2? When cosine is what? 1/2. So what values give me cosine value 1/2 between 0 and 2 pi? Pi over 3 and what? And 5 pi over 3. So these are my solutions. Okay? Just because this didn't lead me anywhere does not mean I don't have solutions because I have 2. Does that make sense? Does that make sense? All right. Last example today. And she's saying yes, yes. She's ready to go. Secant x plus tangent x equals 1. Now you know we have to leave the class with a bang, right? Have to leave with a bang.
The tricky one?
Huh?
The tricky one?
Probably. We have to leave it with a bang. What I want to do here is I don't want to, convert these. It's not going to get me anywhere. But remember, secants and tangents pair up well. Remember? Especially when you have secant squares and tangent squares. Right? So, if I take this tangent to the other side, and then if I square both sides of this equation, I can get my secant squares and some tangent squares, can I not? So let's square both sides.
We can just make a square out of it?
Yeah. But when you square both sides, what must we do? No, but what must we do? We have to check solutions. Remember, squaring both sides of an equation will cause us sometimes to have extraneous solutions. So when y'all remember when you square both sides, like when you had the square root of something equals something, you square both sides, you have to make sure to check because you could get those extraneous solutions. Squaring can give us things that are not, so we have to check. We can square, but you have to check your solutions. So we have secant squared x equals. What is 1 minus tangent the whole thing squared? And don't tell me 1 minus tangent squared. What is it?
1 plus tangent.
No, what is it? Remember, FOIL, inside, outside, gives you what? 2 tangent x plus tangent. Remember, FOIL, right? All right.
When do you know that you have to square it?
Um,
No, or do you try other things and see if they don't work?
Well, if you try the things, knowing, you have to remember, secant and tangent pair it well, but they pair it well as squares. Because that's a Pythagorean identity, right? Secant and tangent squared.
Remember how if you could have it squared, you could put it back and use it as this, but you can't do the opposite unless you square it first.
Yeah, you have to get your squares to square it. Hold 1 second.
I think you just answered my question, but so, like this,
We'll get to
sin
yours.
squared x plus cosine squared x equals 1. That don't mean sin x plus cosine x equals 1.
Oh, no. That does not mean that. Does not mean that. Where the 2 tangent is? Okay. We have 1 minus tangent x squared is 1 minus tangent x times 1 minus tangent x. Right? That's what that means. And we use 4. 1 times 1 is 1. We have negative 1 tangent x, another negative tangent x, and a positive tangent squared x. And this gives me what? Negative 2. Because you have to 4. You have to use 4. Okay? So, let's see. Where do we go from here? Secant squared. If I put this 1 plus tangent squared together, what is 1 plus tangent squared? What's 1? It's secant squared. Okay? So if I subtract secant squared from both sides, this totally cancels out, doesn't it? And I have 0 equals negative 2 tangent x.
Is there a different way to do this problem?
Probably. There are more. In math, generally, there will be more than one way you can do a problem.
Is there an easier way to do this problem?
I don't know. Go home and try it and come back and tell me if there's an easier way.
I started off by subtracting the 1 and secant x plus tangent x minus 1 equals 0.
No, that's not a correct statement.
No, I subtracted 1 from both sides.
Secant x plus tangent x minus 1 equals 0. Okay, and then where would you have gone?
I don't know. That's when you start doing it that way.
You don't have to square. I mean, we could have turned that secant squared x into 1 plus tangent squared and then did some things, but
So
you know.
the reason you squared it just because you looked at it and just mentally knew that you had to square it and that give you an identity.
We saw secants and we saw tangents.
Right.
And secant squares and tangent squares can somehow get us
You knew it
to cancel them.
Okay.
Now, I can divide both sides by negative 2, so I have 0 equals tangent x. So, what values of x will give me tangent 0 between 0 and 2 pi? Tangent is sine over cosine. That means what has to be 0? Sine, right? In order for tangent to be 0, sine has to be 0. So where's sine 0? Sine 0, 0. and pi. Am I finished? No, because I squared both sides. I must check my solutions. I have to check my solutions when I square both sides. Remember, the other ones we didn't check, but we didn't square both sides either, did we? Squaring both sides forces us to check. So let's perform a check. Let's do x equals 0, and then we'll do x equals pi. And I check this against what? The original equation here. So, is secant 0 plus tangent 0, is that 1? What's secant 0? 1 over cosine 0 plus what? Tangent 0 we know is what? Is that 1? Cosine 0, I'm putting theta, that should be 0. Cosine 0 is 1, and 1 over 1 is what? 1. Cosine 0 is 0, so that's 0 over 1, which is 0. So yes, 1 equals 1, that checks. 0 is a solution. We go to the original equation. We put in 0. Okay, cosine 0 is 1, right? So 1 over 1 is 1. Sine 0 is 0. Cosine 0 is 1, so we have 0 over 1, which is what? 0. And 0 plus 1 is 1. Now that was 0. How about pi? I need to look at secant pi plus tangent pi. Is that 1? So this is 1 over cosine pi plus sine pi over cosine pi. What's cosine pi? Negative 1. So 1 over negative 1. Sine pi is what? 0. Is this 1? Well, I have negative 1, and that is not 1, right? Negative 1 is not 1. So that means pi is not a solution, but 0 is. Okay? Whenever you square both sides of an equation. Right. That produces what's called extraneous solutions. Any questions about what we have done today? Any questions?